In the previous session, we have looked at successive differentiation. Let's say we have to find the fifth derivative or sixth derivative of a function. Now it's going to be a painful process if you have to go step by step, y1, y2, y3, and in that order. So there should be some kind of a formula by which we can directly find the nth derivative. So let's look at some of these formulas for the nth derivative. Let's start with y is equal to x to the power of m. Now y1 is equal to s, y2 is equal to y3 is equal to, now the pattern itself becomes very clear now. This will keep going till m minus n. Yes, look at the pattern now. Here it is second derivative, it is 1 here, 3, 2. So 1 less. So here n means here it will be n minus 1. X to the power of m minus n. Okay. So now let's look at this. Does this remind you of something? M into m minus 1 into m minus 2? It should, because this is nothing but m factorial. Now it doesn't go up to 3 times 2 times 1 kind of thing. It stops at m minus n minus 1. So first of all, we have to make it go up to 1. M minus n plus 1. Yeah, this is the simplification of this. So the next one will be m minus n, and like that it will go up to 2 times 1. X to the power of m minus n. Yes. So we have to divide the expression by the same, so that the net effect is nil. 2 times 1. So now we can write in factorial notation. M factorial by, this starts from m minus 1. So m minus n factorial x to the power of m minus n. An expression which doesn't contain any y1, y2, y3 kind of thing. So we can directly apply this formula for the nth derivative. Now here, if m is equal to n, then what will it be? Just understanding the formula. So if m is equal to n, what happens to yn? M factorial divided by m minus m factorial times x to the power of m minus m. This would be equal to m factorial by 0 factorial x to the power of 0. Now here you know 0 factorial is 1, x to the power of 0 is 1. So if m is equal to n, yn will be equal to m factorial. Now if n is greater than m, what happens then? Without actually trying to substitute it, just look at it logically. Let's say we have x to the power of 4. So y1 would be 4x cubed. y2 would be equal to 12x square. y3 equal to 24x. y4 is equal to 24. y5 equal to 0. After that it will be 0. Now here this is n. This is m. So n has become greater than m. So what has happened to yn? Yn will become equal to 0. Okay, let's look at the next one. See, these are standard functions. The idea is to have formula for these standard functions so that it becomes easier for us to convert other functions into these forms and directly apply the formula. Let's say y is equal to ax plus b to the power of m. Now y1 is equal to m ax plus b m minus 1 times a. y2 would be m into m minus 1 times ax plus b m minus 2 a square. y3 is equal to m times m minus 1 m minus 2 ax plus b to the power of m minus 3 a cube. Yes. Now the pattern becomes clearer, and we know what this m into m minus 1 m minus 2 becomes. It becomes m factorial by m minus n factorial times ax plus b to the power of m minus n and a to the power of n. Again, just like in the previous function, let's say m is equal to n. What happens? If m equal to n, yn will become equal to m factorial will remain as it is, denominator will become 1, ax plus b to the power of m minus n will become 1, and we will be left with an. Now, if m is less than n, yn will become equal to 0. And just one special case. See, here the assumption is that m is a positive integer. Right? Just one special case. If m is equal to minus 1, what happens? Let's see what happens. Y is equal to ax plus b to the power of minus 1. Right? So y1 would be minus 1 to the power of ax plus b minus 2. y2 would be equal to minus 1 times minus 2. Let's keep it in brackets. ax plus b to the power of minus 3. Now times a. We should not forget that. y3 is equal to minus 1 times minus 2 times minus 3 times ax plus b to the power of minus 4 a cube. Let's add one more step. y4 is equal to minus 1 minus 2 minus 3 minus 4 ax plus b minus 5 a4. So this pattern will go on. Yn will become equal to what? Now here let's look at each one of them. This is negative, this becomes positive. This is negative, this becomes positive, right? So if n is odd, it will be negative. If n is even, it will be positive. So in short, we can write it like this. Only the sign part. Now, if you look at this, 1, 2 factorial, 3 factorial, 4 factorial. So which means n factorial, ax plus b. Now what will this be? M is minus 1 and n is 4. If I say m minus n, so minus 1 minus 4 gives me minus 5. Minus n minus 1. So if it is the fourth derivative, it will be minus 4 minus 1, that is minus 5. A to the power of n. Now this becomes minus 1 to the power of n, n factorial, a to the power of n, and this we can take minus out so that this becomes plus and the whole thing goes out, minus. So which means we can take it to the denominator, ax plus b to the power of n plus 1. Let's look at the next function. Y is equal to log ax plus b. y1 equal to derivative of ax plus b, that is 1 by ax plus b times a. Now the derivative of this we have already seen, ax plus b to the power of minus 1, and that is nothing but this. So yn is equal to minus 1 to the power of n. But here we are starting from y1 is this, right? So nth derivative would be 1 less. So it will be n minus 1. n minus 1 factorial a to the power of n minus 1 divided by ax plus b n plus 1 minus 1. So n. Yes, remember, because we looked at the special case of minus 1, that is why this was just a two-step process. If we have to properly do it, then we have to actually do this part here. Okay. Fourth function. Let's look at y is equal to e to the power of mx. Not very difficult. This is actually quite. E to the power of mx remains as it is, but the derivative of mx, m will come down. So e to the power of mx. y2 would be m square e mx. And we know that this will lead to yn is equal to m to the power of n e to the power of mx. Fifth one. Let's say y is equal to sin ax plus b. Remember, this makes it simpler. Because once you know this, then you will know for sin x as well. Why? Because b will be 0 in that case. Okay, y1 is equal to, now sin is what? Derivative. Cos ax plus b times a. But remember, cos can be written as sin ax plus b plus pi by 2. So which means now y2 would be cos ax plus b plus pi by 2 times a square, which can be written as sin ax plus b plus 2 times pi by 2 a square. y3 would become 3 times. So basically this pattern would be yn is equal to a to the power of n sin ax plus b plus n pi by 2. Now if we have to look at y is equal to sin x, if we look at the previous function, a is 1 and b equal to 0, right? So which means the previous function itself we can apply a to the power of 1 sin a is 1, so x plus b is 0 plus n pi by 2. So which means a sin x plus pi by 2. Yes, okay. Let's look at the next function. We looked at sin, so naturally the next would be cos. Cos ax plus b. y1 equal to minus sin ax plus b times a. Now this can be written in terms of cos. So what happens? This minus becomes plus. So cos a cos ax plus b plus pi by 2. Remember, cos pi by 2 plus x equal to minus sin x. Okay, y2 is equal to, again, a square, because this, when we differentiate the internal expression, we will get another a sin. So which means again minus ax plus b plus, convert it into terms of cos, the negative sign will disappear. Okay, and again this minus will disappear because of conversion to cos. Cos ax plus b plus 2 times pi by 2. Let's do one more. y3 is equal to, now if we differentiate this, we will again get minus a cube sine ax plus b plus 2 times pi by 2. Now this again we convert it into cos. So this minus will become plus. So a cube cos ax plus b plus 3 times pi by 2. So now you got the pattern. So yn would be equal to a to the power of n cos ax plus b plus n pi by 2. Let's do the next one. 8th, let's find the derivative of y is equal to e to the power of ax times sine bx plus c. y1 would be, remember the rules remain the same, ax, sine is cos. So cos bx plus c times b plus, we left it as it is, we differentiated this sine. Now we differentiate eax times a and leave sine as it is times sine bx plus c. So which becomes equal to eax is common. So eax cos bx x plus c b cos bx plus c plus a sine bx plus c. Yes. Now this is where the next step is the crucial one, and this you can't follow linear thinking and do it. Here what we want to do is somehow get this into a form, say cos theta sine or cos a sine b plus sine a cos b. We want b to be sine and a to be cos, so that we can apply the trigonometric identity. Sine a cos b plus cos a sine b, something like that. Now what do we do? Remember, a is equal to r cos theta and b is equal to r sine theta. If we do like that, a square plus b square would be what? A square plus b square would be r cos square theta plus r sine square theta, right? If we take r square common, cos square theta plus sine square theta. Now this is 1. So we are left with r square. So a square plus b square equal to r square. That is one thing. Second thing is we have cos and sine. Using that we create one. We don't want two separate ones. We want one also. One single trigonometric ratio. So that would be tan theta is equal to, remember, sine r sine theta by r cos theta. So these two gets cancelled. We are left with tan theta. Now this is nothing but b by a. Now if tan theta equal to b by a, then theta is equal to tan inverse of b by a. Okay. So now let's go back to our y1. Now what is happening here is, if we substitute a and b with this, y1 is equal to e to the power of ax r cos theta sine bx plus c plus r sine theta cos bx plus c. What will happen? Identity wise, this is an identity now, because r we can take it out, eax, r is common, we can take it out. We are left with cos theta sine bx plus c plus sine theta cos bx plus c, which is sine a plus cos a sine b plus sine a cos b. So which is nothing but sine bx plus c plus theta. So which means if we compare it with the y expression for y, what is the change that has happened? The change that has happened is we have multiplied it with r and we have added theta. So which means to get the next set of derivatives. It's just a question of adding or multiplying it with r. So this becomes r square, and adding theta to it, bx plus 2 theta. So in general, yn would be r to the power of n eax sine bx plus c plus n theta. Now you might wonder from where will this r come, since in the initial statement we don't have r, but we do have r here. R square is equal to, remember, a square plus b square equal to r square. So r will be equal to square root of a square plus b square. And theta, what will be theta? Theta will be tan inverse of b by a. So the jump in our thinking has to be at this point. Cos bx plus c, sin bx plus c. Okay, so we need b and a also in terms of sin and cos, so that we can apply trigonometric identity. And then you have to remember a equal to a cos theta, b equal to r sin theta. If you are familiar with unit circle, this will come, because r will be the radius of the circle. Let's look at the next one. Which one was it? 9th. Y is equal to a to the power of mx. y1 would be equal to ma to the power of mx times log of a. y2 would be m square amx times log a square. y3 would be m cube amx times log a square, cube. So which means in general yn is equal to m to the power of n a to the power of mx log a to the power of n. Now if we are interested in the derivative of nth derivative of a to the power of x, it's just a question of making m equal to 1. So yn equal to 1 to the power of n, a to the power of m is 1, so 1 into x log of, which is equal to 1 to the power of anything is 1, a to the power of x log a, which is nothing but ax log a. Let's look at the next one. Okay, y is equal to log of square root of 2x plus 1 by x minus 2. Now remember, the moment you see a log, see whether you can simplify it first. So y is equal to, remember, this can be written as log of 2x plus 1 by x minus 2 to the power of 1 by 2. So because of the properties of log, we can bring that half down. So half of log 2x plus 1, yes, 2x plus 1, and the division becomes subtraction. So log x minus 2. So now it's a question of differentiating these separately. Half of, now did we look at log ax plus b? I am sure we would have done it somewhere. Log ax plus b, this particular expression. Okay, let's look at this. Let's write out that log ax plus b. Now yn is equal to minus 1 n minus 1 factorial a to the power of n minus 1 divided by ax plus b to the power of n. So here what happens? Minus 1 to the power of n minus 1 times n minus 1 to the power of, factorial a to the power of, now a here is what? 2 to the power of n minus 1 minus, and here divided by ax. Ax is 2x plus 1 to the power of n minus same one n minus 1 n minus 1 factorial, and here it is 1 factorial because here a is 1, divided by x minus 2 to the power of n. It's a lot of things in common, so half of minus 1 to the power of n minus 1 is common, n minus 1 factorial is common, 2 to the power of n by 2x plus 1 to the power of n minus nothing is there here, so 1 by x minus 2 to the power of n. By the way, here we are applying the nth derivative directly using the standard forms. I think that's enough for today. Bye for now.
Please go to the about page of my channel, and here you will find various links for each topic. These are Excel workbooks which I have been using in many of my videos. Download it and practice.